In this talk, we would like to basically share our experience building a platform to measure commercial mobile networks in Europe. The platform is called MONROE, and it is basically an EU project, a Horizon 2020 supported project. Hence, we have 7 partners and a long list of authors. So mobile networks has become a critical infrastructure. So we use it in our everyday lives. We use it in health services. We use it in fleet manager systems, and security forces also use it. So it is essential for us to be able to understand, especially in large scale, how these commercial networks work, how is their stability, how is their performance, how is their availability, and can we come up with metrics to basically quantify this. To address this need, we basically built a platform called MONROE. The main difference from a crowdsourced platform, for example, is it is a hardware-based platform, so it's basically available 24/7 for experimentation. Of course, it has a smaller scale. So we basically design, build, and operate this platform. It's a European scale, open platform, and it's a flexible platform in the sense that you can basically plug different modems and measure their performance the same way you measure mobile performance. So our main goal was with the platform is basically, can we identify the mobile broadband performance metrics? And this will basically enable us to accurately, realistically, persistently, and meaningfully monitor these networks. We also wanted to take one step further and focus on innovative services. So 5G is around the corner. So can we basically design experiments, or can we design new services that we can already test on the commercial networks and provide guidelines for the upcoming standard? So meet the MONROE node. What does MONROE node do is basically it connects simultaneously to multiple operators. In this case, 3 mobile operators, for example, AT&T, T-Mobile, and Verizon in US. And it just basically accesses internet through these mobile operators. And then you can basically experiment on these operators. We have an experiment deployment system. So you basically design your experiment and put these experiments to the node. You run it, and you gather the results. To accommodate multiple users, we have a user-friendly scheduling, user access and scheduling system. One of the main goals for us is basically not allow more than 1 user at a time on the nodes, so that you have full access and you can basically measure the performance or stability of the networks. You don't have any cross-traffic. The network is just for you to be able to run your experiment. If you have a closer look into how does the node look, in order to accommodate basically 3 operators as well as a Wi-Fi, we go for an APU-based design. So we have 2 APU systems. It turned out to be a very stable hardware for us to use. So we basically have 3 modems. It is basically the most recent modem that is available in the market. And then we have a Wi-Fi modem, so you can basically access 4 interfaces, 3 mobile interfaces and a Wi-Fi interface at the same time. Our experience reaching this point, when we started this in 2015, we were using MiFis. These are basically small routers with batteries. But the experimentation requirement of this platform was too heavy for the MiFis to handle this. At some point, our MiFis started to get fatter, so we have some battery bloat issues. This imposes, of course, some security-related things. But with the current design, no battery, the system is quite stable and no security issues. So in terms of deployment, where do we put these nodes? So we, first of all, put these 2 APUs in a box, and then put these into people's houses, offices, train stations, or schools. But we also have mobile deployment. What does it mean? We put these nodes also on trains, buses, and also trucks. But as you can imagine, having such a remote system, so it's not a platform that you run in your lab when you basically go troubleshoot and fix the problems. So it needs a software system design to be able to remotely access it and troubleshoot. So we basically need to make sure that the node is self-healing, so when some problem occurs, it can repair itself and still come back up online so that we can reach it and do the troubleshooting. And we also wanted to have prevent unauthorized access to the platform. So we have a strict firewall on that. And what do we do in terms of experiments? We basically allow you to deploy your experiment, but the platform also runs continuous experiments all the time. So you also have access to the data of those experiments if you would like to use that data. If you want to have a closer look into the software ecosystem, we would like to, first of all, really isolate the user experiment with all the software that is handling management and maintenance-related activities. So we first decided to use a virtualized environment. So we use a Docker lightweight virtualized environment. So everything the user has happens in a Docker container. We also have an internal NUT function, which also separates the interfaces, the real interfaces from the container. So we provide virtual interfaces to the users. This basically enables us, if something happens when you are running an experiment and you accidentally do something wrong, it doesn't impact the real software running on the node, which basically keeps it online all the time. Another important aspect here is basically when you are running a measurement, context information is very important. You need to know the technology, you need to know the signal strength, you need to know the GPS if you are mobile. And this is also provided to your container in real time. And we basically have some connectivity measurements, some speed test measurements, some traceroute measurements that continuously monitor the state of the network all the time. So when it comes to experiment scheduling, as I mentioned before, it's important for us to give access to the node one person at a time. And this basically requires some resource allocation. And it's also a little bit challenging to have a scheduling system for mobile systems because the node can be out of coverage, so you might not access the node. So you need to basically have a system which can accommodate these requirements. On top of this, you have data quota limitations of commercial mobile subscriptions. So you need to keep a balance about this. And our solution for this was a calendar-based approach where basically you can schedule an experiment at a period ahead, and then you basically are given a certain number of nodes and certain data quotas. And if the node is not available, you also have assigned a low priority queue, so you can run your experiment at a later time. And this has been working quite well so far. Using this system, our users has run more than 100,000 experiments in the course of maybe more than a year. So one interesting instrument in EU project, at least in our project, was open calls. What does this mean? Basically, when we are running this project, we want people to join us to make software and hardware improvement. So first of all, we wanted to understand the users of this platform. What do they want? How we can fulfill their expectations. So we invited some users to join us, to join the MONROE community to help do this. So we basically run 2 open calls. In the first one, we have around 40 applications, and we basically selected 12 projects among those applications, and some of them were basically extending the platform, putting nodes in other places, and some of them were just trying to run different experiments, innovative experiments. And in the second open call, we have 50 applications. And among them, we basically selected 15 projects. And we are currently supporting 27 different experimentation and extensions. So before going into what type of experiments we can support, I would like to say it was very useful experience for us to get these external users, because throughout our interaction with them, the platform has evolved quite a bit. So we get their feedback, we improve the platform, and whoever is designing a platform, especially an open platform, I think it's very important to consider this during the process. So in terms of experiments, what do we support? So we have many different stakeholders. So we have users like customers who would like to see which operator is best, interested in different benchmarking related things. We have different businesses, for example, the trains who provide Wi-Fi services. They want to know what is the best mobile operator to buy so that they can provide the best Wi-Fi service to their users. Of course, regulators are interested in this. They want to basically see whether the operators are fulfilling their requirements. Operators themselves are interested because they are basically tested based on regulators or other parties on this. And of course, the research community. We would like to enhance the state of the art, and we would like to basically come up with new ideas and algorithms and test them. So in general, we basically have three main areas that the experiments are running. The first one is basically mobile broadband performance. I divided this into two because one of the main parts was basically to understand what is happening today. And then I have the tomorrow part where I will basically discuss what we need to do to go one step further, but how we can basically design the next generation networks. And some of our users in these open call users basically focus on understanding what is happening in mobile networks today. So we have some users focusing on benchmarking. They are building coverage maps. They are building speed maps or application maps. So basically our nodes that are mobile collect GPS information. They traverse the route multiple times. So you basically have a more robust information on these measurements. So you can provide more robust coverage maps. Some of our users focus on analytics. So they would like to basically understand whether there is some anomalies in the network happening and whether they can detect it using such a platform. Some of the people are interested in network neutrality aspects. So how to tackle network neutrality in today's commercial networks. And some of our users are interested in characterizing mobile content providers in the wild. So all these smartphones using the content delivery networks all the time. What is the interaction and what we can learn from it? And taking it one step further, we have users that are interested in connected cars. So analysis of latency critical connected vehicle applications. Are we ready for the autonomous driving, and what we need to do to go there? We also have even interesting applications in the smart grid domain. So they want to understand the latency and reliability of mobile networks and their contribution to smart grid. Can we even use that in smart grid? We have self-organizing networks where you basically use machine learning to basically learn what is happening from the user perspective and use this to optimize what is happening in the network, in the RAN or in the core network. And we have also emergency communication related activities. Are we ready, or will 5G be ready to use these networks for disaster situations, emergency communications? The other aspect of our focus is on service-oriented experiments, focusing more on the quality of experience. So we have many web-related experiments. You can basically run different web performance measurements. And you can also run a lot of video applications. Especially in our first open call, we have many applications that are video related, especially from industry. They would like to basically either build a product or find a way to improve the video quality. So you can consider Dash-like video on demand or more interactive type of applications. And there were also some people who would like to do even multipath, since our platform supports multi-homing. And the other aspect was app performance. There's many different apps in the App Store that they would like to understand how is the interaction with the communication part, and can they design better apps that people are happier, especially under mobility or bad communication channels. And finally, we have innovative protocols and services. So here we have internet path support and transparency, where we investigate the many middle boxes that exist in these networks. We have multipath protocols. This platform supports kernel modification. So if you have a multipath protocol, you can basically go and test it. Since we have Wi-Fi and 3G, you can also do traffic offloading. This was also very interesting for multiple parties. And you can also take it one step further and do protocol innovations. So test new applications, new protocols. QoE is coming up, even it is in the user space. You can test QoE, for example, on the platform. So this is my last slide. It's basically just giving you an overview of our coverage. We started in Norway. Currently, we are in 4 countries, in Sweden, Italy, and Spain. And we have 150 nodes, and we are increasing in terms of that. With additional open call users, we basically increase this number towards 200, and we are very happy to accommodate your needs and maybe even further increase our coverage. We test, or we can measure 12 different mobile operators in Europe. And in November with IMC, we will basically open this to the whole community, not only our external users, but you can be one of MONROE's users. If you are interested to joining the MONROE community, please talk to us. We have a couple of papers in WinTech on Friday on the workshop, but you can just email me or email info@monroeproject.eu, and after November, hopefully you will be one of our users.